In today's video, we're going to discuss how to find the area and perimeter of composite shapes, and we're going to learn that through doing several examples. Right, to find the area and perimeter of composite figures, we must complete the following steps. We will use the figure below as our first example. So step 1, divide the shape into its individual simple figures and fill in any of the information about the composite figure that you can. So if I look at my shape here, this is a composite figure because it's made up of 2 or more simple figures. Now there's multiple ways to split this shape up, but the first one that I saw was to drop a vertical line here and divide this into a rectangle and a triangle. Somebody else might have seen drawing a line across here, and then you would have a small rectangle and a larger trapezoid. Either way, you'll get the same answer. So as you practice these, you're going to have to figure out what you see and what you're most comfortable with. Again, I like to do the area and perimeter of rectangles and triangles more than a trapezoid because a trapezoid is a little bit more complicated, but again, there are multiple ways to do these questions. All right, so then we need to fill in all the information that we know. So in this rectangle here, we do know that this has to be 4 inches. That's already labeled for us. But since rectangles opposite sides are congruent, this is also 4 inches, and we're going to go ahead and label that. Okay. The height of my entire rectangle is 8 inches, and then I have a height here of 2 inches. So to figure out the height of this triangle here, I would have to do 8 minus 2, which makes this 6 inches. And again, it's important to label all of these pieces so you don't forget. All right, same idea across the bottom here. Okay, this whole length is 10 inches. So I have a 4-inch section from here to here. So 10 minus 4 is 6. This is going to be 6 inches across the base of my triangle as well. So I notice that I'm missing this side length here, but I can find that if I use the Pythagorean Theorem. So my right angle is here, making my hypotenuse across. So I have my Pythagorean Theorem, a squared plus b squared equals c squared. So a is 6, I'm going to plug that in. 6 squared plus b is 6 here, so plug in 6 there as well. And that's equal to c squared. We know that 6 squared is 36. 6 squared is 36. So we have 36 plus 36 equals c squared. 36 plus 36 gives us 72. And in order to solve for c, we would take the square root of both sides. So we have the square root of 72, and that's going to be 8 point. We're going to round to the nearest hundredth today. 8.49 is equal to c. So my side length here would be 8.49 inches. Okay. So now I have everything labeled. I can find the perimeter by adding up all of the side lengths. So you pick a side, it doesn't matter where you start, but you want to make sure you only add each side once. So I have 4 plus 8 plus 10 plus 8.49 plus 2. And remember, perimeter is the distance around the outside edge. So one more time, we had 4 plus 8 plus 10 plus 8.49 plus 2. And those are what? And you should end up with 22.49. Since perimeter is distance, this is going to be measured in inches, and that would be my final answer. To calculate the area of a composite shape, we have to calculate the area of each individual simple shape, and then we label them in a diagram so again we don't forget as we go. Okay. First thing we're going to do is we're going to find the area of this rectangle. We know that area from a rectangle. So I'm going to put A and a little r so I know that it's a rectangle. Our formula is going to be length times width. So the length of my rectangle is 8 inches and my width is 4 inches. So area of the rectangle is equal to 8 times 4. So the area of the rectangle, 8 times 4 is 32, and that's measured in inches squared. The area is measured in square units. So I'm going to write 32 inches squared on the inside, and I like to circle my areas so I don't get them confused with the measurements for perimeter. Okay? The area of the triangle. So the area of the triangle is going to be the formula 1/2 base times height. So if I look at my triangle, the base is across the bottom 6 inches, and the height is also 6 inches. So that makes the area of my triangle 18 inches squared. So again, I'm going to label that 18 inches squared inside my triangle and circle it. Alright, and then to find the total area of the composite figure, we simply add the two simple shape areas together. Sometimes you have to subtract. We'll see an example of that on the next page, and then that'll give you your total area. So we're going to add 32 plus 18, and I believe that gives us 50. Yep, 50, and always include your unit, so this will be 50 inches squared. All right, a couple more examples. Okay, so if we look at our second shape here, we have a rectangle and a triangle again, pretty straightforward. All right, we are missing some of the pieces though, so we want to make sure we label everything first. So on this rectangle, the length is 9 and the width is 7, which means this side is also 7 meters. Okay, now if you notice here, we have an isosceles isosceles triangle. Those two side lengths are the same measurement. And we're missing this side length here. So we're going to have to use Pythagorean Theorem again to find that. Okay, so I know across this bottom here, this right here is splitting the length of the rectangle in two. So here is going to be 4.5 meters, and here is going to be 4.5 meters. Okay, so I know that the height here is 6, and my length is 4.5. If you look at this triangle right there, that's our right triangle that we're going to use Pythagorean Theorem on in order to find the length of this side. Okay, so I'm going to use a squared plus b squared equals c squared. So my a is 4.5, so 4.5 squared, plus b is 6, so 6 squared is equal to c squared. 4.5 squared is equal to 20.25, plus 36 equal to c squared. So I have 56.25 is equal to c squared. Take the square root of both sides, and I end up with 7.5 is equal to c. So I know the length of this side is 7.5 meters, and I know the length of this side is 7.5 meters. So now I can go ahead and find my perimeter by adding up all the side lengths. So I have 9 plus 7 plus 7.5 plus 7.5 plus 7. Notice you don't use any of the internal measurements, so we're not using the 4.5s or the 6 here. Perimeter, again, is just distance around the outside, so sometimes it might help to use a highlighter or some sort of color tool to help highlight that. All right, add all those numbers up, and you get a perimeter of 38 meters. To find the area, again, we find the area of each piece separately, and then in this case, we're going to add them together. So we have a rectangle and a triangle. Rectangle here, triangle here. Okay, so area of a rectangle is length times width. We'll do that one first. So the length of my rectangle, we already stated, was 9. And the width is 7. So the area of the rectangle is 63 meters squared. And again, area is measured in square units. Area of the triangle, formula is 1/2 base times height. So we have 1/2. Base of the triangle is all the way across. So that's going to be 9. Height of the triangle, from the bottom to the highest point, is going to be 6. So we multiply all that together, 1/2 times 9 times 6, and we get the area of the triangle as 27 meters squared. So our final result, we're going to have to add those two areas together. So my total area is 63 plus 27, and that means my area is 90 meters squared. Next example is a little bit interesting. You see here you have a rectangle, but you have a triangle cut out of it. So this is one where we're going to have to use subtraction. Again, we have an isosceles triangle here. Both of those sides are the same length. So that makes it nice when we're trying to figure out the base of the triangle. Okay, we know this whole side here is 13. We know that this is 4 and this is 4. So we can use subtraction to figure out what this missing piece is here. So 4 plus 4 is 8, and we need to get to 13. So we can do 13 minus 8 makes this 5 meters across the base of that triangle. And because it's an isosceles triangle, that means this piece is going to be 2.5 and this piece is going to be 2.5. Right? So now we're all set up to use our Pythagorean Theorem to find the length of the legs here, or the length of the hypotenuse of that triangle, and then, so this length here. So same formula, a squared plus b squared equals c squared. Okay? A, we use 6, plus b is 2.5. We're looking at just that small right triangle there, so 2.5 squared is equal to c squared. So we have 36 plus 2.5 squared, which gives us 6.25, equal to c squared. So 6.25 plus 36 is 42.25. And we're going to take the square root of both of those. And we end up with 6.5 is equal to c. So we know this here is 6.5, and we know this here is 6.5. So then again, perimeter, we just add up all the side lengths. So pick a place to start and go all the way through. So here's 8 plus 13. Other side of the rectangle, I forgot to label, is also 8, right? These two are congruent. So plus another 8, plus 4, plus 6.5, plus 6.5, plus 4. All right, add those all together. And you end up with a perimeter of 50 meters. And again, we don't use any of the internal measurements here. That 6, we don't use it. Those 2.5s, we don't use it. We only use the measurements that are found along the outside of our composite shape. Okay? Area, we have a rectangle, and we have a triangle. But this time the triangle was a cutout. So instead of using addition, we'll have to use subtraction. So area of a rectangle is still length times width. And the area of a triangle is still 1/2 base times height. So for my rectangle, length 13, width of 8. That gives us an area of 104 meters squared. Area of the triangle, 1/2. Base of the triangle is that whole bottom distance, so that's going to be 5. And then the height is from here to here, so that's going to be 6. So we have 0.5 or 1/2 times 5 times 6. And we get an area for the triangle of 15 meters squared. So since this is a cutout, the area of the entire shape is going to be the area of the rectangle minus the area of the triangle this time, not adding them together. Again, this is a cutout piece. So I have area is equal to 104 minus 15. So that means my area is going to be 89 meters squared. All right, last one. We have the paint of a basketball court, and we're trying to find the area and the perimeter of it. So we notice here we've got two shapes. I see a semicircle here, and then I see a rectangle here. That's how I would divide that up. Okay, so if we're going to start by labeling everything we know, this is 19 feet, this is 12 feet. That means this distance is also going to be 19 feet. These two sides are congruent in a rectangle. And I need to find half of the circumference of that circle. It's a semicircle. So I know my diameter of the circle is 12. So in order to find circumference, I can use the formula for circumference, which is pi times the diameter. And since I'm only using half of a circle, or a semicircle, I'm going to divide this by 2. So my circumference would be 3.14 times the diameter of 12 divided by 2. 3.14 times 12 divided by 2 gives me a circumference of 18.84 feet. So I know the distance around this semicircle is 18.84. So perimeter, add them all up. So I can start with that 18.84 plus 19 plus 12 plus 19. Again, perimeter, outside edges, might help to highlight it. Okay. Add those up together, 18.84 plus 19 plus 12 plus 19, and you get a perimeter of 68.84 feet. Okay. And then to find the area, again, you find the area of each sheet separately and then add them together. So we have the area of the semicircle and the area of the rectangle. So area of a semicircle, you take the area formula for a circle, pi r squared, and you divide that by 2. So remember, if our diameter is 12, our radius is going to be half of that, or 6. So the area of our semicircle is 3.14 times 6 squared divided by 2. Remember, order of operations, you have to square the 6 before you multiply. So we're going to have 36 here, 3.14 times 36. And we're going to divide that by 2. And so the area of our semicircle should be 56.52 feet squared. Area of a rectangle, formula is length times width. So my length is 19. My width is 12. And we have the area of the rectangle at 228 feet squared. So my total area, I would need to add those two numbers together, 56.52 and 228. So my total area is going to be 284.52 feet squared.